You've probably heard me say this quite a lot when I speak at the AI Hub, and that is, if you're not making mistakes, you're not doing anything at all. It was approximately a year and 2 months ago when we landed an opportunity at Durham College at the AI Hub to start working with computer visioning technologies. Now, for me, it was my first foray into that space of computer visioning. And I remember talking to some of our student researchers who had never done something like this before. We knew it had been done, but we were suddenly coming outside of that space that we call our comfort zone. So, to echo a quote I said earlier, I decided to take my team down the path of being a little comfortable with being uncomfortable. Now, with computer visioning technologies came this really interesting opportunity to look at how we could work with visual data, with images, and how we could parse out intelligence from it and act upon it. And I remember close to about 2 to 3 projects later, many a times in each and every one of these computer visioning projects, we found ourselves at a point where 2 of the 3 panelists in my group today would actually look at me and say, I don't know if we can go beyond this. And my response has always been, keep going. You didn't come this far just to get this far. We can cross that finish line. Now, as they've come to know, for me, there is no finish line. I keep moving the post ahead until they tell me that they found a job in industry, and then I replace them with somebody else. But that's the magic of applied research. Today, for the next 40 minutes, we're going to be tapping into this magic that is computer visioning and learning from 2 students, as well as 1 newly minted industry individual at Precise ParkLink, how computer visioning, touchless authentication, and these kind of new models of service deliveries are imagining themselves and rendering ROI for companies across Canada. My name is Hirji. All of you know me as the lead at the AI Hub. I'm looking forward to the next 45 minutes with you. And then, of course, for the last keynote on hacking smart contracts using machine learning. I'm going to ask my panelists to introduce themselves. And in my typical style, I'm always going to throw in a little bit of curry flavor into it, starting with Mr. Josh. Now, Josh, we always say that if Bob Marley went to school to study computer science, he'd look like Josh. So Josh, tell us a little bit about what you do at the AI Hub and what got you interested in this space of computer visioning. Josh, over to you.
Understandable. Well, first of all, computer visioning, there's so much that you can do with it. And so I've always been interested in it just for that. So I've worked at the AI Hub on projects where I've helped develop basically AI to detect objects out in a field autonomously with robots. I've worked on a project involving processing different bands of data from the Sentinel-2 satellite, in which we use to train a model to detect different kinds of wetlands in the Taber and Lubicon areas of Alberta. And then more recently, I've been heavily involved with integrating a DLib model and custom gaze tracker for use in the medical industry, where we are automating and gamifying some current in-person tests, which are typically done in clinics, and bringing that online so it can be done at home with a webcam.
Yep, and you're one of those students who's always been like, no, I'm going to push harder than I did yesterday for a better tomorrow. And one of the things that have served you very well at the AI Hub is A, access to companies willing to take a chance, but B, access to data sets and multiple data sets with which you could actually test your models with. So we're going to go through some of those experiences with Karachi Innovations, Eurovision Therapy, and get to see a little bit about your perspective from there. My next person is another fascinating student at the AI Hub. I got to know him very discreetly as someone who knew quite a lot about computer visioning before even coming into the Hub. And he's been one person in all of our meetings who ultimately becomes our test model for almost every implementation. So if everything fails, he knows that if somebody's looking for a model to test a computer visioning tool, he is well prepared for it, because every time we have to test optical movements and head movements, we always test it against his wonderful head and his wonderful presence. Mr. Faizan, it's good to have you on your first ever panel discussion. Super proud of you that you took us up on this invitation. Tell us a little bit about, in this case, what are you studying at Durham College, or what did you complete studying at Durham College? And what got you interested in working in computer visioning? Faizan?
All right. Oh, thanks for having me here. So I've been studying basically the postgraduate certificate program at Durham College in artificial intelligence implementation. So I finished that recently, and computer vision's been something I've been kind of fascinated for a while. Back in high school, I actually took this robotics program where it was basically a competition between different schools that used to come in, and they'd have a robot. We have like an autonomous period where you have to use computer vision and sensors and stuff to accomplish different tasks. And I found that very interesting, and I thought we can implement that into like real life scenarios. So automated eye testing, video processing, and stuff like that. That would be pretty cool. So I ended up basically learning about AI Hub and working with you guys here. So ever since I've started at the AI Hub, I've had the chance to work on some pretty cool projects from taking pre-recorded videos of like say traffic on the road, detecting different types of cars in it, and then tracking them throughout the video to see where they're going, what the traffic conditions are like, and processing those, as well as doing stuff with live webcam feed to conduct automated eye tests where you'd normally go to a doctor and you'd sit in front of her and she'd conduct a test. So in this case, the user would sit in front of their webcam and we do the whole facial landmark detections, eye tracking, and everything, and then they'd be able to conduct a test sitting at home without having to physically go to the hospital or the clinic or anything like that. So especially in these COVID times where you gotta maintain that social distancing, that type of stuff is actually becoming more and more useful and convenient for people. So.
Absolutely. And one of the other things that has been absolutely fascinating about working with you is the fact that many of these models at times were new to you. And you did a lot of self-study in order to begin analyzing how to deploy them. So we'll dive deeper into them. And last but not the least, a partner, his firm is a huge partner of Durham College, been with us since the very beginning. Jerry from Precise ParkLink. Jerry, I believe you've recently joined the team at Precise ParkLink. Tell us a little bit about what you do and how you're touching computer visioning technologies at PPL. Jerry?
Yeah, so I'm a new junior application developer at Precise ParkLink, and the products I'm currently working on are our ParkLink web app, our ParkLink Android app, and our hospital check-in system. So like when I do with computer vision, it would be in like our hospital check-in system where we sort of just scan a user's face as they authenticate and just check in for their visiting appointments. And we also have other sources of AI in our other projects where we have like our license plate recognition in our Park Suite system or our parking assist system where we just check if they are in like the correct spots.
Yep, absolutely. And Jerry, I'll be looking to dive deeper into that with you and look at some of those implementations. I also know, Jerry, you are in the midst of a busy work week and you are joining us from your office. And I do appreciate that you've taken this time. So Josh, I'm going to start off with you just a little. And one of the things that I've constantly said when we've been talking about computer visioning, when we've talking about deploying these kind of models that look at interacting with people beyond speech and look at interacting with folks visually, it really is not about, hey, we need to find the right answers or we need to find the right sort of solutions. We need to ask the right questions. So I want to ask you, and slightly off script, let's take the example of when you started working with neurovision therapy. You went through this process of asking the client what it is that they wanted to deliver from the model. How do you go about talking to clients? What questions do you ask them when it comes to computer visioning products? Josh?
Well, obviously, it all comes down to the outcome and what you want at the end of the day. Because if you're making a model, you need to know exactly what needs to go into it in order for, getting a result that's good enough for the client, something that the client wants. And if you go into it with assumptions and you think, right, I think it would be good for the model to do this, I think it would be beneficial for this, and you don't think about the client's end goal, you might end up spending a month developing something that ends up not being used. So it is imperative. You need to talk to the client about what they want at the end of the day. You need to know what results the model needs to give you. And if you don't go through a weekly process of talking about that and refining those outputs and reconfirming pretty much on a weekly basis that this is what we want and this is the direction that we're going with it, Yeah, it's really important to just reconfirm with the client all the time about what their end result should be.
Absolutely. And I think this is where the key comes in, right? Is that, I've emphasized this. So when you want to work with developments or you're going to use computer vision models, design is at the key of it. There's never no design. It's either good or bad design. And I think those moments when we start asking the client, how do you want your patients, for example, to interact with this model? Do they have to be at home? Do they have to log in through a web browser? I think everybody gets infatuated with computer visioning, and we're going to have cameras that can detect and tell you this, and that, and capture so and so data. But they forget about the UX UI component, in which you've done a very, very important job. Josh, just to let you know, you've got a bit of a fan club as well. A few people have come on the chat and said, "Good to see you, Captain Marley." So you know what? Good for you, Josh, and for your first panel engagement, you're definitely stirring up the crowd a bit. So Faizan, you've got some big boots to fill here. So short of singing a song, we'll jump straight into the next question. And Faizan, I want to ask this one to you, because when we talk about computer visioning, just so that our audience understands, from an AI hub perspective, we don't just have to think about, okay, we're going to get some visual data and then we're going to parse it and annotate it. We've also got to ask other questions around hardware. Now, Faizan, I remember you, especially in the neurovision therapy project, spending a lot of time talking to the client about, what kind of cameras do you have? What are the angles that you're going to take the pictures from? Are there live feeds, etc.? Can you help our audience understand how you've worked with the clients on that front?
Right. So before you can train a computer vision model or anything like that, you need to take a look at what kind of data you have available, what kind of input you'll be getting from the user. And then you need to train a model that's going to be able to handle all sorts of different inputs. Because when you're making a computer vision model for the general public to use, you're not going to be in a certain lab settings with perfect lighting conditions, perfect camera angle. Like, their head could be in various poses. It can be turned to the right, up, down, left, right. They can have like very bad lighting or very good lighting. So those are all things you need to compensate for. And then as well as what kind of minimum camera quality we need to have in order to be able to detect very detailed features. For instance, with the near vision, where we're doing the eye tracking, you need to be able to detect your pupils. Now, pupils are a relatively small portion of your face compared to the rest of your face. And now for that, you need a pretty good clear picture in order to be able to see the user's face and detect the pupils inside that. So we have to talk to the client, hey, so what kind of data will you be able to gather? Like, will you be able to get users in different settings with different head positionings, different lightings, and then we can use that data to train a model to detect the user's face and stuff like that. As well as we need to set a minimum threshold for camera quality. So hey, if the user doesn't have this minimum camera quality when conducting the test, we're not going to be able to say the test results are good with a certain degree of accuracy, because sometimes we may be able to detect their features, sometimes we may not be able to. So depending on how they're running it live or pre-recorded videos, what kind of FPS, like what's the FPS? Like, is it able to record like 30 frames per second, 60 frames per second for the camera? What kind of video quality, 720p, 1080p? So for generally, we try and minimize like at least 720p video quality, which is like, going to be good enough for most tasks. But then there's other camera factors that kind of come into it, which you can't really control, such as the image sensors, the lens on the camera, which is kind of out of your control. So those are all things you got to try and compensate for, and then set some sort of a minimum threshold. And now at the end of the day, it kind of comes down to your problem. Now, if you're doing some sort of object tracking where you have large objects, then you can maybe get away with some worse cameras because the object is pretty big. You can track it pretty easily. But when you get into like detailed stuff, you need higher and higher camera quality. So at the end of the day, it depends on what you're trying to do. But I would say somewhere around 720p is something that would work generally well for most tasks.
Absolutely. So you know what? And again, if all else fails, besides being a model for computer vision technologies, this person knows his cameras in and out. So for those of you who actually want to get into computer visioning, understanding the hardware component of it is not just important, it is actually extremely essential, because that hardware component generates and captures the data that you require. And especially if you require live feeds of that data, having the right camera quality, the right angles for that camera are absolutely essential. And this is why I always say, right, it's not technology that changes the world or changes the experience. It's the thoughts and the dreams and the ideas behind that technology that really create that revolution. So speaking about that, Jerry, I know that it's slightly early days for you at Precise ParkLink, which is really an innovative leader in the world of parking technologies. Can you talk to me a little bit about some of the applications? Recently you've launched some touchless endpoints. Now you've launched some items with computer visioning. Can you tell us a little bit about what you're working on?
Yeah, so the main computer vision project that I'm working on is our check-in system. So like the authentication for that is mainly facial scanning. So when a client goes in, they already have like the appointment book, and when they walk in, scan their face, just make sure that they have all the passes. It's not fully like touchless as there was in our solution right now. There's still going to be a touch pad because the user has to answer like the certain questions just to make sure that they have a temperature that's not over 30 degrees that they don't show anywhere. But aside from that, our system currently still measures their temperature using like a hand scanner, and then also just make sure that they're the only visitor with their single patient as well, because visitors that can be within the hospital too.
Not a problem, Jerry. And thank you for explaining that. For everybody that's watching, the team from Precise ParkLink, if you go to their website and you go onto their social media, you'll see a lot of different posts about the different products that they've launched and how these are changing the parking experience. And as always, Jerry, I can see your team. It's hard at work in the background. So of course, please make sure you go on mute, Jerry. As always, thank you for your comments. Josh, I'm going to bring you, my man, back into the conversation. And listen, you and I share a bit of a love for, sometimes just sitting back and taking a chill. We often say to each other that life was a lot less complicated when BlackBerry and Apple were just fruits. Now we've got all of this data to work with, and we've got all of this nonsense that we need to annotate. It's one thing with computer vision technologies to capture the data. So Faizan comes in, smiling like he's modeling for toothpaste as always, and says, I've got the camera, I've got the data captured. Now you need to annotate it. What are some of those challenges when it comes to annotating data? And I think you could also reference some of the work that you did with Hirji Innovations and how annotation became particularly challenging. Josh?
Right. Yeah. So first of all, there's a lot of different kinds of annotations for images. So, I mean, it depends on if you're doing like boxed annotations versus like polygons and whatnot. But at the end of the day, data needs to keep consistent and unique so that the model has, the greatest amount of opportunity to learn and doesn't really get confused about what it's trying to learn. It's also extremely important to make sure that the data set is both balanced and unbiased. And especially for neurovision, when we're dealing with computer vision models which deal with people, the AI needs to be built so that everyone has a similar experience and an equal representation in the data set. And so, yeah, this is a big thing, is keeping the data set unbiased. I think that's the biggest part.
Absolutely. And for our audience, just to understand the issues with some of this bias. Now, I'll take a couple of minutes and just set that into context. And of course, I'm going to go into professor mode, meaning I'll put on my glasses. No, I won't. I just had this for effect. Here's the thing. When it comes to understanding bias in the model, yes, there are models, expert systems, et cetera, that you can train on biased data sets, and then they render biased responses. But I always go back to issues that happen when you train computer visioning models on video data, on text data, on images, et cetera. How many of you remember the time, and I've spoken about this quite a bit, when a particular major technology conglomerate started to build a computer visioning model and started training a model on multiple images from multiple sources. One of the elements of that result was one of the outputs would render people with darker skin as a particular type of animal. Now, I don't need to go into more deeper context around that, but you realize when you get it wrong, it can have severe socioeconomic, socio-political ramifications. And Josh, I think it's particularly neat that you flag that in the work that you do. So thank you for that, Josh. And Faizan, I'm going to loop you back into the conversation because you work sort of hand in hand with Josh, and you're sort of that pinch hitter that comes, gets the data in, and then allows us to move on to other items as well. Can you comment a little bit about some of the challenges that you find when data has to be annotated but in real time. Sometimes when you have to annotate data after the fact, you've got the luxury of a little bit of time. You've got the luxury of a little bit of space in which to annotate. But when you're doing it real time, it can get particularly challenging. Faizan, some of your thoughts on that?
Sorry, just to clarify, you mean by real-time annotations, you mean like right before like model training, or like the
In both
annotations?
cases. In both cases.
Okay, so oftentimes, like, you know, like you're getting the data and you maybe perhaps you're short on time or stuff like that, and you need to get the data pre-processed. So it's good if you can get like you know, you before the whole process begins, you talk to your client, you know exactly what needs to be in there. What are the classes or labels, categories you're going to have? For instance, if you're working with animals, like, you know, you have cats and dogs and whatever animals you choose to have in there. So you know beforehand, like, hey, this is the data we have. You get together with your team, and a problem you can often run into when you're doing annotations is when you're doing annotations using some sort of a software, whether real time or beforehand, you have to basically give it a list of all the items you have. And if your list is basically associates an index with the list, so say 0 for dog and 1 for cat, and then when you do the bounding boxes, basically you annotate the data, which is kind of, and it might be slightly complicated, but like when you draw bounding boxes, it associates a number with that data. Now, if your data is not consistent throughout the team, then it's gonna, the whole bounding boxes, the annotations are not gonna be consistent. You're gonna have to go back to the data and reformat it to make sure all the team members' annotations match, they're in the exact same format and stuff like that. So that is something you'd have to take care of. And again, how much data you have to annotate. So that would be a big problem. So those are things you'd have to consider.
And I think that makes a complete point that, you know what, even when we start working with our clients, the key question that you end up asking them is, what kind of data do you have? And if they don't have that data, going and looking for synthetic data sets to support that. Jerry, it's a good opportunity now to bring you back into the conversation. When it comes to training different AI models, when it comes to produce, especially using visual data, or perhaps in your case, interacting with the eye movements, head movements, even touch sensitivity, how do you train some of your models? And do you find anything challenging, particularly with finding data for training computer vision models? Jerry?
Yeah, a lot of the time, it's hard to create because if you want to do something, normally you have no idea how it works going in. And then you just have to read a lot of papers and just have to create things from scratch and or TensorFlow. When it comes to like annotating, yeah, like a lot of the projects that we have here, it's hard to find like data from like a first-hand source. So a lot of the time, first thing I do is I go online, see if a data set already exists before going out and grabbing my own for what we have.
Yep, absolutely. And, you know, this is one thing which when I was talking to Josh as well as Faizan, and, you know, we've been working with Abhilash, we've been working with Sabah, you know, we're working with a whole bunch of different professors in terms of developing and deploying these models. You know, accessing these data sets could get very, very interesting, but challenging at the same time. And that's what I will say for people who are beginning to use or thinking about using computer visioning technologies. Knowing those data sets, or also knowing what synthetic data sets you can get access to on Kaggle or anywhere else, is absolutely essential. We've got about 10 more minutes left. And Josh, you know, you and I have had this conversation all the time that intelligence is really creativity that's having fun. You've had to be creative with certain things. You've had to have fun, but you've also have to use existing libraries. Now, our default has always been to talk about YOLO libraries, but can you give our audience a sense of what are some of those Python libraries that you use in computer visioning and your perspective on them? Josh?
I mean, to actually train them, there's a handful that, I mean, beginners I would recommend. I mean, TensorFlow is obviously one of the biggest ones out there. And then, of course, you have the other supporting ones like Curaz, NumPy, Pandas, you know, some newer ones like the sklearn, IMBlearn, some things like that. I'm sure I'm pronouncing a lot of those wrong, but they are really, 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 really important when it comes to training AI, because if you go to create all of it from scratch, it will take you a long, like it'll take you a year probably. So if you can utilize some libraries like TensorFlow, for example, It gives you a lot of out of the box things to create your model and to add layers to it, set up the nodes properly, choose what kind of model you want, and, make all of the inputs. It manages splitting data itself. So yeah, there's a lot of really powerful libraries out there for beginners and for advanced users as well, because it's good.
Josh, I'm going to keep you on the hot seat for just a little longer. And just before I do that, one of my colleagues, Isabella, when she was hearing this feed, she mentioned about the bias element. And there's a documentary called Coded Bias, which she recommends that people watch. I haven't actually watched it. So I know when people talk about AI these days, that there is one documentary that they often refer to. And that documentary is The Social Dilemma. I thought you guys would have known it.
Yeah.
But you did not. But
That's
add another documentary to that list called Coded Bias. Thank you, Isabella, for sharing that with me. But Josh, keeping you on the hot seat just for a little bit more, I want our audience to know you actually didn't necessarily come to school to study AI. You're in the computer science programming, and you suddenly found yourself doing AI. Was that, I mean, you didn't really have a choice with me, but was that particularly daunting for you, Josh?
It was exciting. It was extremely exciting. That was what I was going there for, pretty much. I mean, obviously, I didn't go to school for AI. I went to school for just computers in general, because computing is amazing, and there's a lot of power behind all that stuff. Now, getting the opportunity to work with AI was a door opener. Because when I got to college, seeing the AI hub, the second I got there, I thought, I want to work there. It seems like the future, in terms of how things are going. So yeah, getting into it and actually learning and figuring out that, yeah, I am going to be doing AI and I am going to be working on a couple of cool projects. That was exciting. It was way more exciting than it was daunting, because like the amount of things that you can learn and the amount of support from beautiful colleagues working there and all of that, it's the perfect place to learn. Perfect place to learn new things.
Absolutely. And I remember meeting you the first time. One of the things that I'd said that, with AI, really, it's not that the future is ahead of us. The future is where we're at right now. Yes. You got to seize that opportunity. And I think this is an extremely important trait. And I know Jerry and Faizan will agree with me at this as well. Is many folks come into AI tabula rasa, not really knowing much about it. Mm-hmm. You've got to have those safe spaces to test. And as I said in sessions before, I quoted Edison, where he said, I've never failed. I've just found 10,000 ways that do not work. Yes, now, yes. Josh and Faizan have found more than 10,000 ways that do not work, but that's a separate story, and we've dealt with the industry partners satisfactorily in that regard. Faizan, I want to bring you into the conversation with a similar question as well, and that is, you started working with these models for the first time. Did you create any test beds or anything, to sort of test if your model is going where you want it to go before actually coming to the meeting and saying, "Hi, Ali, here's what it is"?
Yeah, of course. Oftentimes we'd, maybe use like a small subsection of data, just train a very simple model, just to perhaps one or two classes compared to what we're going to have, just to see, is it giving the kind of results we want? Are we having the speed we need? Like in case you're trying to do real-time detections with a model, then speed becomes very important. So you need to find that kind of trade-off between accuracy and speed. So it depends on which model you use. So we do some demo models and stuff like that, make like one or two different types of models, test them out, not with all the entire data, just a couple of them, and then see, are we able to actually do the predictions in real time at a reasonable speed, right? Like if maybe not 30 FPS, but like 15 FPS or 10 FPS, something like that, where you can see it happening in real time in front of you. So we do a bit of testing, and then we, show it to you in the meetings. Hey, this is giving promising results. We can try it out, see as we add more data to it, what kind of results we're getting. And then from there, we can see, hey, these are the changes we need to make, perhaps try a different approach and that stuff.
Yeah, that word promise. I can't promise you that I'll get you where you want to be, but I'll get you where you need to be. And that, Mr. Faizan, was the very smart philosophical way in which you've got through many of those meetings. But jokes aside, I think it's so important that folks realize this, especially you've got quite a few prospective students and folks who are interested in getting into AI. The beauty about working at the AI Hub is those test beds, the ability to go and creating a safe space to fail. If you look at Josh, for example, one of his first projects was with Dr. Vivatiagi. I think it was, if I'm not mistaken, Acreage Way. And then you went in Karachi. You went through this whole process of learning, making a couple of mistakes, and growing from there. And now with projects like neurovision therapy, Canatom, and now a couple of other ones as well, I think you're well positioned. And the same with you, Faizan, you're well positioned. Jerry, I'll bring you in for the last question for you, and then we'll come to a soft landing. And Josh and Faizan, I told you, nothing to be worried about. Not everybody's a pro like Jerry, but now we'll go to Jerry and let him give us some closing remarks from his side. Jerry, at Precise ParkLink, are you creating opportunities in terms of internships or opportunities for students to be a part of your work and to build on AI models with you? Jerry?
Yeah, we're hiring right now, but like since I've come in, like we've taken on a number of different projects going with AI. Mainly, like I don't know too much past like the checking system that I'm currently working on, but yeah, we like love taking in new grads and just getting them position series, like see what you're capable of and see what like new ideas you can bring to the table in terms of like thinking through traditional problems and then seeing how you can think outside the box and just come up with solutions that are useful.
Yeah, and I think it's truly fascinating because when you think about parking, you don't necessarily think about the innovations that are possible in that space. But then we look at how far you folks have come with innovating with different areas of parking, different areas of technology, and implementing AI into that has been an extremely important piece, especially in light of the pandemic. So in keeping with that question of the pandemic, Jerry, if I can get you to unmute once more, how impactful has the pandemic been on your AI developments? Has it made it even more urgent for you to go down using computer visioning technologies for your services? Jerry?
Yes and no. Obviously, since the pandemic has happened, our checked-in system has been pushed to the top of the list of priorities. But at the same time, we had some like ongoing projects that were on the back burner, such as like our AI assistant kiosk, which was sort of this computer vision and natural language processing system, which would help like a user answer any questions they had about how to navigate our systems. Like that one, of course, had like a touchpad. And since global pandemic, no one wants to touch a touchscreen anymore, especially one that's public. So yeah, it's a little bit of both.
Yeah, absolutely. Well, Jerry, thank you so much for your perspective. We are coming close to the end of our session, but I'll go around with one last question to everyone. And this is going to be completely off script. All of these individuals are representing the fact that, excellence in AI, it's a process. It doesn't just happen by accident. You go through a process of learning, trial and error, and the right support systems. Faizan, I want to put you first up. You've worked at the AI Hub now close to about 3 semesters, so that would equate to about 1 year. Can you tell me about one memorable moment for you working on computer visioning, and one moment where your model hit that point where you're like, wow, I am the next best thing after sliced bread? Can you tell us about one memorable moment you had?
For sure. Actually, going back to the project we're currently recently working on with the neurovision, we're doing eye tracking. So when we first started off, we were struggling to just get that pupil detection working. Like we just, for some reason, we were able to find the eyes, but we just could not get the exact location of your center of your eyes kind of working. So it was just the whole trial and error process. We'd be trying different computer vision models, different types of techniques, switching models, like see, hey, maybe if you go with a different type of model, which is giving us higher accuracy compared to speed, or, just changing the, adding more data to it and stuff like that. And it just, it went on for a couple of weeks. It just would not work. And then eventually, with the right parameters, right data set, right hardware configuration, which was very important as well, to right camera quality and everything, we finally got it working. So that was pretty exciting. That was a whole learning curve. Got to learn a few different techniques, see what worked, what didn't work, what worked well for different settings. So that was pretty interesting. Yeah.
Yeah, I'll tell you this much, is that we do have ourselves a bit of that luxury where we can reflect on how far we've come and reflect on some of the mistakes. But in the world of business, the rear view mirror is always cleaner than the windshield. Sometimes it's easy to look at the bad side. I wish I would have done things differently. But the good thing about working at the Hub, especially as we've delved now deeper into computer visioning technologies, is that we've got a background of a lot of historical work that we've done to reflect on. And Faizan, I want to thank you for being one of those students who didn't necessarily step back at the opportunity, step back at the challenge. None of us had done this work before. You embraced it. You could have sunk with us or soared, and I really believe that you soared. So Faizan, always nice to have you, and thank you for your perspective. Josh, let's come to you now, my man. And I've always been telling you this, that when we look at some of the work that we do, sometimes, it's not just about having lots of data. Sometimes you need to have very specific data in order to get to that end result that you want. Right. Can you tell us about one moment at the AI Hub which got you thinking, hey, you know what? This place ain't so bad. Ali is tolerable, but everything else ain't so bad. Josh.
Oh, yeah, there's a lot of those moments. It's hard to pinpoint a specific one, but I think if I would, it would have to be for Solstice, where we were dealing with a crazy amount of data for basically annotating wetlands. So we had, I think, like 12 different bands of data and a whole bunch of stuff. And we were running surprisingly low on data, even though we had so much CSV stuff. And so we had to come and use computer visioning stuff. And we came to you basically asking for high resolution images from Alberta, Tabor, and Lubicon. I think we only did it on Tabor at first to test it. But yeah, we requested a bunch of images, and you guys were able to basically go down there and get these super high fidelity images from the Sentinel-2 satellite going over Alberta. And that was really motivating because it was something I thought was unreachable, something I thought like, I don't think I'll be able to get my hands on this, but it'd be really cool if we did. And we did quite easily, actually. So yeah, it was awesome.
Yeah, and you know what? I actually remember that moment very well. That was a project we did with Abhilash, if I'm not mistaken. Yeah. And then we had, of course, Vibha leading us from the administrative side. We've always held this, computer visioning is relatively new for us. We've done a lot of stuff in NLP, a lot of stuff in machine learning and deep learning, but you've seen me as well, even with the neurovision therapy project, we've been a little nervous about it. And every time we're walking with caution and extreme caution in some cases. But you know what? The reason we were able to do that was because just the style at DC, and I think you'd agree with me. Our style, if the best way to put it is that it's not necessarily a management style, because management is kind of like you're telling people what to do. Leadership is when you allow people to achieve their full potential, and that's the beauty of what we have at the Hub. And I'm really, really, truly thankful to have someone like you who not only aspires other students, brings out confidence in industry partners, and more importantly than that, keeps it cool runnings at the Hub, and everything is airy when someone like you walks in because you've got that presence. So Josh, thank you so much for everything that you do. And the last question to Jerry, from your perspective, if you had to talk about trends that you see in computer visioning, bring out that crystal ball, what's one trend that you see happening in the future with computer visioning?
Yeah, I guess if I'm allowed to plug a project for my alma mater, U of T, we have this project called like the Toronto Annotation Suite. I can look at it in the chat actually. There it is.
All right.
But it's pretty much just like a project that uses computer vision to help annotate more pictures for computer vision. So Joshua mentioned earlier how important it was to have unbiased data and properly annotate data. The Toronto Annotation Suite is basically a tool to help you like segment your picture into like wireframes and polygons, and help like people just annotate images the best of their ability. And I know that they're currently trying to get it to run on cell phones, but even like right now, it's a auto-generated wireframe. It takes like 5 seconds on like a full desktop GPU. And like on cell phones, I think that we're gonna see like a lot more AI running like natively on your cell phone as well with
absolutely
like, processors.
Absolutely, and I think cell phones being one of those key components in the world of computer visioning. And again, we know that your team is working hard in the background, so you can go back on mute, Captain Jerry. But thank you for that. And I think you've pointed out a very important lesson, and that is our cell phones are going to be one of those things that are going to propel more and more use cases with computer visioning. There are issues around privacy that come in. There are issues around compliance that come in. But I really recommend to the audience is that some of the libraries that are out there that you can currently use will allow you to run some basic models and learn how to eventually refine some of those models. With that, gentlemen, Jerry, Josh, Faizan, this was a slice. Life's too short to remove the USB key safely. I'm glad that you took this risk and you joined me for your first ever panel discussion. I know we just went over the high level aspects of computer visioning, but I'll tell you what's important in all of this. You've showcased that at a very young age at Durham College, our students are producing some prototypes that are going to not just recreate, not just revolutionize the industry, but also echo in a new evolution in how we think about how to do research and development in this growing field of AI. So I thank you for taking the time. I'm going to ask you to stay on while I let the audience know that I know that there was a couple of issues in this session with the stream. I do apologize for that. Sometimes we cannot control the internet connections. However, all of the sessions will be available next week on demand on cyberexchange.ca. Shout out to the CyberX team for hosting that for us. And we've now come to the final session of the day, and that's going to be on hacking smart contracts using machine learning. I invite all of you to stay on and enjoy that 45-minute closing keynote by Tushar Singh from Minute School and Starship Dreams. This is your host, Ali Hirji. And before I turn it over to the break and then we have Tushar close things off, I want to thank everybody for their time. I want to thank all of the sponsors, including Precise ParkLink, for making this day happen. The team at Town of Aurora, Town of Ajax, City of Oshawa, Invest Durham, Connects Health, Sheer Brilliance, CyberX, let's see who else, Cora, so many others of you that have supported this conference. BlockSec Technologies, thank you so much for your support, and thank you to our students. We will see you in the next, I think, approximately 15 minutes as we kick off the final keynote. Stay safe, stay healthy. This is Ali Hirji signing out from Enable AI 2021, and I'll definitely see you at Enable AI 2022. Enjoy the closing keynote, and we'll see you in 15 minutes.